Well, good morning wherever you are, and I really mean wherever you are, as we're live streaming from here at the Phoenix Cinema in Kirkwall to an expanded audience online, and indeed we've heard from people in various places that they're planning to join us today. This morning's topic is something that is of vital importance wherever you live, and extremely timely. How to tackle the big global problems we face in a fresh and systematic way. That approach would be music to the ears of the two people to whom this annual Grimond Lecture is dedicated. Joe and Laura Grimond were in the true radical tradition of public life, where the word radical is from the Latin radix, which means root, and their radical approach is to go to the root of the problem. It's the opposite of going for what's popular in the short term or following focus groups or opinion polls or lobbyists. It means a systematic, scientific approach, and indeed the radical approach developed at the time of the Enlightenment, in the wake of the new thinking that came with Newton, and indeed the development of the whole modern scientific worldview. The two speakers today have developed methods for going to the roots of the massive global problems that face us, going to the roots and systematically developing solutions. And it will be possible for everyone in the audience, wherever you are, to put questions to them at the end of their presentation. From a distance, there is YouTube chat. Here in the audience, we have a traveling microphone that will be going round. And in addition, there is Slido. This is a new system that we've added in this year. And you can see the details about it. It essentially involves either your phone or going directly onto the Slido site. I should say that although in theory you can use your phone in the room here to attached to it, in practice phones could be a problem in case somebody needs to call you during the presentation, so it's safest if you wouldn't mind to keep the phone off during the session. But now for our speakers. And back in 2009, two people came up with a phrase and a name and a concept that embodied what we'll be hearing about today. The phrase was transition engineering. They were both engineers and they wanted to find a way to help to make a transition to a better future. Between them, they developed tools, engineering tools, that will enable changes to be made to tackle climate change, dependence on resources, general issues of sustainability, to tackle them in a systematic way. One of them is Daniel Kenning, who's an engineer and environmentalist. He left Ford in 2001 to run a specialist engineering for sustainability company, Splendid Engineering. Co-founder Susan Krumdieck's background is in mechanical engineering. She studied at the University of Colorado Boulder and Arizona State. She was at the University of Canterbury in New Zealand for 20 years, and she became Professor of Engineering there in 2014. She's now Professor of Sustainable Energy Transition Engineering at Heriot-Watt University and based in Stromness, and it's my pleasure to hand over to them.
Thank you, Howie. We need to change over to our Prezi now. Oops. IT. Whatever this is. There we go. All right. Thank you for coming along and for joining in online on YouTube. Daniel and I are presenting together. We've done tag teams before, like at the COP26. And so we hope that you enjoy this dual version of our presentation.
Okay, good morning. The news that we read seems to be getting worse and worse. And today, a third of Pakistan, a third of the whole country of Pakistan is underwater as a result of climate change. In America, there is a rocket waiting to be launched, which is capable of going to the moon, and all of the technology and development and money has been invested in that rocket that can do that amazing thing. And we have to ask ourselves, do these things represent a really sensible approach to the problem? Are we doing the right things? Are we going in the right direction? And we're going to talk about how you can actually change the direction that we're going in to go in a better direction. So in the next 40 minutes, we're going to do three things. First of all, we're going to shake it up a bit. We're going to talk about the scale and importance of tackling the problem, and with this picture illustrates a recent film that some of you might be familiar with, and we're going to talk about what climate action really means. Then we're going to look at the mechanisms of transition engineering. We're going to make the case and present the evidence and show you that there is a way that we can change direction and move towards what we call a human-safe future. And then we're going to talk about and try and convince you that your participation in transition, all of you, through your groups, through your community, through the place where you work, how your participation is possible and important and necessary. So let's get on with it. And first of all, I'm going to pass to Susan, who is going to shake it up a bit for us. Thank you, Susan.
All right, thanks, Daniel. Looks like we've had a technology glitch here, but we'll move on by handheld mic. Now, the only problem with a handheld mic is that I sometimes forget that I'm doing science and and change to stand-up comedy. So just be What's the difference between a scientist and a stand-up comedian? A handheld mic. All right. All right, Professor down. Here we go. Let's shake it up. And in order to do that, what we're going to shake up is our existing good intentions and our existing good projects that we're working on, all right? The things that we all are pretty comfortable with because they're business as usual. But because they're business as usual, they've been failing. All right, so let's talk about this. This is the measurement of the atmospheric carbon dioxide concentration measured by the National Oceanic and Atmospheric Administration of the United States. Have you seen this before? Yes. And what it shows is that from 1959, the measurement has been taken and it has been going up. Why did the United States start taking this measurement in 1959? Well, Congress actually funded it in 1957 because of the concern about climate change. That's why. Because too much carbon dioxide would cause the earth to warm up, etc. And so a treaty was agreed by the nations of the world that the carbon dioxide concentration should not go above 350 parts per million because that would change the climate. You remember that? Anybody old enough to remember that? All right, so there was a 350.org, there was protests, there was climate action, and I'm telling you, that's all business as usual now. Scientists giving warnings, the United Nations getting together, treaties being agreed. That is business as usual, and it is continuing to accelerate the problem. So what we think might be a slight problem is that the target. We think it's a safety limit. And now IPCC latest report has come out with very good modeling showing that in fact, if we get to 450 parts per million, there's a 60% chance we're going to overrun 2 degrees warming, and that is going to be catastrophic. We would call that a failure limit in engineering. And a failure limit is something that you change everything to not actually get to. So if anybody says the word target around 1.5 degrees C or 2 degrees C, you say, no, that's actually a failure limit. We're not going to go there. And in order to not go there, do you know what has to happen? Something big, something that is not what we're already doing. All right, so that's what we're looking for. What is that? It's the mission 2030, not that by 2030, but today, to get to a 2030 that is on the right path. What has to happen? Well, this is my reconstruction of the IPCC data from the modeling that shows what we have to actually do. Why is that not in there? Maybe there's a miscommunication between science and engineering. But the point is that what they've done is they've calculated essentially what we would call failure limits. The load to failure for the climate is 800 gigatons of fossil carbon burned with oxygen and put into the air. The historical experiment tells us how much of that there is, how much we have left, and this is that budget. So to have an 80% probability of not exceeding 2 degrees C, the fossil fuel trajectory has to follow the green line, the one on the bottom. If you look at the top line, a 3% per year reduction in fossil fuel production, that would give us a 2% chance of not blowing up the planet. In engineering, that wouldn't be a thing. That C minus, oh, maybe a D. Oh, that's not okay. We wouldn't do that. An F, that's a fail. So do you get what we're saying? We've recast the problem statement that what must be done is an 80% reduction in fossil fuel within the decade to 2030. Do you agree with that? Because if you don't, you're going to have to answer to Ayla. This is an 18-month-old. She gets what she wants, right? Ayla wants that chance. Think about that. She's 18 months old now. 2030, she won't even be in middle school yet. But the future will be decided by then. All right? So the mission is an 80% fossil fuel downturn. What we're doing with fossil fuel right now, 80% less of it. Is that pretty easy to understand? To get an 80% chance, 80% downturn of fossil fuel. Pretty clear? All right. How does that make? Is that a mission? How in the heck could we possibly? Because collective. Don't Look Up movie? All right. You who have, because you should, very good satire of the way we deal with problems like this. They spot a meteor coming towards the Earth. It's a direct hit. It's, and nobody will listen to the scientists who are getting more and more urgent in their, and the president is sort of making a joke of it. And so it goes like that, like you would predict. And the world gets hit by a meteor and is destroyed. So there you go. Spoiled. So I want to change the ending because that's not an acceptable ending. It's kind of interesting Hollywood-wise, but it's not acceptable. So what we're going to do is we're going to retell this story quickly. And that is that, yes, indeed, a meteor is spotted 20 years away. It's out there by Neptune. It's 20 years away. So we've got 20 years. Or do we? Don't we actually have to do something right now in order to have any chance? So right now, 20 years to go, the space agencies of the world get together. They say, look, okay, if we throw everything at this so that we can get something off the Earth on the way, everything we've got right now, we can't have any new technology, we just put it up there. It'll take about 20% of the resources of our economy to do this. But in 10 years, that craft that we put up today will intercept the object and maybe destroy it. We don't know. So next year, we got to put another one up, and the next year, and the next year, and the next year. In the 10 years we've got left, every year there has to be another craft intercepting this object, ready to do whatever it is we've learned we need to do next. So we need to be agile, active. 20% of our economy every year we have to dedicate to saving the planet. Is that doable? And the answer is, of course it's doable. That's a no-brainer. So the doable investment now changes the ending and saves the future.
So clearly, what we're talking about is how to change the direction of the trajectory that we're on at the moment. At the moment, we are not static. We're on a trajectory that Susan has called business as usual, and that includes all of the good stuff that we've been trying to do for the last 70 years or more, which has actually made no change of direction at all, unfortunately. So we've got to work out how can we change the direction of our whole society from the direction that leads towards danger and disaster and climate change and catastrophe and extinction of human beings towards a better future. We're not talking about less bad, we're talking about more good. We're talking about how to move the whole system so it's going in a different direction. And this diagram here of a set of railway points shows how a small mechanism, set of points that can be operated by one person, can actually change the direction of a 1,200-ton moving train. That's an engineered system that allows a change in direction of a large object with a small input. And so transition engineering is about small changes that can be made by a small number of people, like a community group or a company, all of you individuals joining us today, to change the direction of a big system. And the good news is that there are examples from the past of where a small engineering change has led to a safer future. And that's what we're trying to do now. We're trying to achieve a human-safe future instead of a future which excludes human survival. So in 1911, the situation then was that it was normal practice, it was accepted that there were a high number of deaths in the workplace every year. And in America, a number of, it was actually 62 engineers got together and decided to create a new thing called safety engineering. And the first thing they did was establish standards and safety devices so that people could have fewer accidents in industry. And the numbers show that had in the UK, there used to be 5,000 deaths per year. Today there are less than 200. And had those changes not been made, then there would have been over 8,000 people dying every year in the UK in industry. But engineering was able to make that change. And everyone joined in, everyone participated, but that's an example of what is possible.
Right, so let's focus on safety engineering a little bit, because this is key, that something happened within the engineering professions that changed the future. And it's entirely possible that the politicians of the day never even knew it was happening. The owners of the factories of the day didn't really see it happening until the insurance companies looked at the payouts for accidents and the funeral benefits that they paid and said, wait a minute, those are going down like crazy. And then you started to see the value of the thing that by that time was already 40 years along. All right, so let's look at safety engineering when it was a new discipline. These are line workers at a utility in 1911. Do you think there's any difference there? The biggest difference was probably that your career would be so short that you never even had an apprentice. So it's, yeah, it was a very short cycle job. In 1911, that idea started that, you know what, there really is a problem here. What is the number one thing if you're in industry and you have this problem that the way you are working is absolutely wrong, it's killing people, you deny it. And so the first thing that was so important for the engineers to do was to be honest about what the problems were. All right, just be honest. Does that ring true at all right now? I think it does. Then the second one was to say, well, let's prevent what's preventable. And preventing what's preventable, it turns out in this case that it's hard hats, PPE, straps that if you fall don't kill you, the materials, the reflectivity, there's a lot of gear right there. But there's also a whole protocol of behavior and responsibility. And that is what prevents what's preventable. And think about the engineering. There's nothing actually new there. The artifact, the equipment is new, but the materials, the engineering itself is the same thing they had before, just doing the job of preventing what's preventable. That's huge, remember that. The next thing was that safety engineering is just normal work. It's called duty of care. When you do something simply because you do, We are professionals, and that's what we do. And that is probably the most powerful force that we could bring to bear on downshifting fossil fuel right now on our planet, is the engineering duty of care. Just do it. Don't wait for the policy, don't wait for the regulation, don't wait for the next big protest, just do it. And if you have a successful system, it's profitable, it works fine, it works great. If it needs changing, you gotta change it.
So you can see here a list of different initiatives, engineering initiatives that have taken place over the course of history, and you can see that every time there was a visible requirement for a different way of doing things, a new approach to engineering has emerged. So starting here in 1911 with safety engineering, there was a natural hazards engineering process started after the earthquake in 1906. We've got emergency management, waste management, environmental engineering. A lot of you will be familiar with these terms. Quality engineering from the 1940s and the 60s with the nuclear power. And in my background at Ford, the motor industry in the UK was almost completely destroyed in the 70s because of our lack of quality engineering practices. But today, the companies that adopted quality engineering processes are still trading. The companies that didn't all went bankrupt. They don't exist anymore. There's no such thing anymore. Because we can see the problem of climate and environmental breakdown, and we can see, as Susan has shown, that all of the things that we've tried so far using previously available approaches hasn't actually changed our direction of travel. So it's important to note that all of us have to participate in this. Like in safety engineering, everybody's responsible. So you can see the top picture there of the children wearing goggles in the classroom. Goggles were the first safety engineering product that was engineered, because it was a product that you couldn't make at home. So they had to be manufactured, and they've saved a massive amount of injuries and deaths. Then we have the engineering involved in traffic light systems to avoid car accidents. We've got flotation devices for people in boats. We've got the hard hats and reflective materials on building sites. Even a seatbelt in a car. There's a lot of engineering involved in a seatbelt, I can tell you. And the familiar fire extinguisher. All of these are products that have been developed by engineers to help increase safety. And then the training there, everybody in the workplace has to go through relevant training. And the same thing will happen with transition engineering. And now Susan's going to tell us about this. Thank you.
All right, so we hope you get our thesis, the hypothesis that every time what we're doing that is successful also is causing disasters, death, destruction. The people making the successful thing will correct ourselves. We call it a corrective discipline. And through our duty of care, we will look honestly at what needs to be done, and we will start giving ourselves the projects of doing that. And then, because these are corrective disciplines, it's going to be a participation sport. Everybody is going to actually participate in the changes that happen. So, do try this at home. Transition engineering, again, not business as usual. Now, when I arrived here, we were having another COVID shutdown, so there wasn't much getting out into the community. But I was on BBC Orkney, and I was talking about what we were going to be doing in the Island Center for Net Zero, a big project here to put transition engineering into action and to develop online courses to teach around the globe transition engineering, to really kick this thing off and get it going. And in that discussion, I was talking about how it's important what people value. Look around, what's important to you. Those are the things we're going to grow while we downturn the things that we have to change, right? And a teacher at Glaytoness Primary School in Kirkwall heard that interview, and on her way to school, she thought, let's do our writing project on that today. So she taught the kids how to write a letter, and I got a packet with 36 fourth grader letters telling me about what they value, what they're concerned about with climate change, how when they're 21 years old, anybody need a gut punch? You can have my packet of letters. So I had to do something. This is gut-wrenching. These are little kids. They know what's going on, and they know it's them who's going to be affected. So I said to my new PhD students, my research group, let's do this. Our center hasn't kicked off yet, but let's do our first project with the school. And what is that project? Well, business as usual is not an option. It's not that. What is business as usual at a school? Well, that's not hard to tell you. You probably all know. We are going to achieve the 80% downshift of fossil fuel in 1 year at Glaytoness School this year. We're going to make things better anyway when we do it. And everybody participates. It's fair. It's not about shaming anybody. It's about going to a new culture with new rules in our place where we're doing what needs doing, and that is empowering. So our project, you can imagine, we apply transition engineering, and that's what we do. So we talk to the people, we learn everything we can, we gather data, and we do the engineering. And that's what I'm going to show you here, that process of working through and coming up with the way this is going to be achieved. That's what engineering means, applying science and math to get done what needs doing. All right? So that process, it looks a little like this. Something's really wrong. There's a lot of china breaking in the dining room, and we know that something's wrong, and we're all trying to figure out what to do about it, but our odds of success are quite low. So the process of transition engineering is about removing the blindfolds in a stepwise methodology where we apply engineering and math and science at each step, and we work around to where we've created the opportunity space and the innovation space within which we can see how this change is going to occur, and then we can engineer that change. The process has 7 steps. I'm not going to go into that right now because I'm just going to show you what we did. All right, does everybody know the Glaytoness School, where it is? It's right down the road. It's right outside here. What the first step is to time travel together, so that the teachers, the students, us, we time travel to 1911. 1911 is the only place where my time machine goes. It can only go to years that end in 11. So we go to 1911 and we go to 2111 and 2011. All right, so our first step is to look at Kirkwall in 1911 and to hunt for the schools. Where are the schools? Well, we found it. It's where the council chambers are now, right near the church. It's right in the center of town, as all good schools would be in 1911. How are the children getting to school? 100% active mode. That's how they're getting to school. Are there, what's the technology level at the time? Are there cars in 1911? Of course there's cars in 1911. Everybody knows what a car is. And there was, to your library archivist, there was a car on Orkney, and the kids loved it when the car was driving down the road because they could outrun it. So that's what life was like. Every child walked to school. Every child could walk to school. Were they accompanied? You know that thing that you do now, that you have to go with your child to the school, and then you have to be there when school's over to walk them back or to pick them up in your car. Was that happening in 1911? No. Well, that's weird. Okay, we'll talk more about that. Oh, were there a downside to that? Not as far as we know. We couldn't find any bad things that happened because of that. And over time, as things changed, what we saw is that there was a time when a new school was built outside of town in the 70s. That school's no longer there. It wasn't a great construction, apparently. The cars started coming in. People started riding in cars. But you really didn't see kids being dropped off at school until quite recently, really. Something happened where now you would think it's normal to to put the kids in the car and drive to the school and drop them off and go wherever you were going to go. So we are, people have been researching that for ages. Why did that happen? What's going on? And trying to change it. And it has not, the literature, the research that's been done, nowhere in the world can you change this. So we're going to change it. So our step 2 is to figure out what's going on today at this particular school, not in the whole world, but right here at this school. So we use the tools of the day, which is IT and data collection and GIS, and we work out what the routes to school are, how many children there are, and if every one of those children was driven on their school run to school every day and back, how much fossil fuel is that? Because that is 100% normal. That's allowed. There are some kids who are walking now, actually quite a few at this particular school, but in any given school in America or Canada or New Zealand or Australia, there's no prohibition at all to driving your kid to school. And in fact, if you didn't, the other parents might think you're negligent. All right, so normal. We figure out what's normal today, and that's what has to change. Our next step, though, is to look at the stories we tell ourselves about the green solutions, right? So we looked at electric vehicles, and this year, can we go to electric vehicles to get to that 80% reduction? And the answer is no. We can't. In 1 year, have hundreds of vehicles replaced with electric vehicles. Electric vehicles may be around at some point, but there are other issues with driving your kid to school, like the kids don't get exercise, the congestion around the school, the possibility of accidents. So, that one we're sort of thinking, well, let's not get overly excited about the electric car, shall we? When it comes to little kids getting to school, let's say that isn't going to work this year. We looked at biofuel. There's a lot of agriculture here. Can we take one of the things that's grown here and turn it into biofuel through a factory and processes? If you look at wheat and barley, yes, you can turn that into alcohol. It's the equivalent of about 30% of Orkney's whiskey production for the kids of Glateness to all be using biofuel to get to school. And you'd have to buy new vehicles on top of that. So that's probably not going to happen this year. What about hydrogen? You guys have probably heard about hydrogen. Yeah? Anybody have a hydrogen car? There's one over there. All right, so we have sort of the same problem in that in this year, buying enough hydrogen cars to get our 80% reduction simply isn't going to happen. And the infrastructure that would have to be built kind of blows out the price by a lot. And I don't know if we would expect somebody else to pay so that this school could do that, but the probability that this is going to happen is nil. So we got to move on. Our ideas about what we might do, we have to park them at the side of the road. They've been crash tested, and they're going to just have to wait for later because they're not what we're going to do. Now, it might occur to you, when we do what we're going to do, we won't need those anyway. All right, so our next step is to travel to 2111. We're going to get our time machine again, and we're going to go to 2111. And we're going to look and we're going to say, is our school, well, number one, is Kirkwall still here? 2111. Trick question. Because we have to choose which future we're going to. We can't choose which past we go to. That one's set. But when we dial up in our time machine what future we're going to, we have to be really careful about which one we choose. Because Hollywood's right. There's some bad ones. So we're going to choose the one where everything that needed to be done right now, got done. All right? So yes, Kirkwall is still there. The glaciers didn't completely melt. We haven't had 1.5 meters of sea level rise. We're going to go to the good place, all right? So 2111, Kirkwall's still here. Is St. Magnus Cathedral there? Has it lasted another 100 years? Of course it's still there, yes. The old ruins are still probably there, too. And what about the Lightness School? Is it still there? I think it is. It's in pretty good nick. It'll still be there, and kids will still be there. So now let's start looking around the community, and what we know for sure about the trajectory that gets us to the safe future in 2111 is that petrol is not being used for consumer activities, conveniences. It's being used for really important things. And children getting to school, personal transport is not where the petrol is. The era of the car has shifted on, and urban areas, rural communities have all reorganized to where they don't really need petrol anymore. They don't need a car anymore. And so what we see in Kirkwall in 2111 is that when it's about that time of the morning, there's just these rivers of kids running around. They're having a good time. They're meeting up with their buddies. They're running down the street. They're getting to the school. What we see is kids with freedom. The freedom of their space, the freedom of motion, the freedom to get together, the freedom to play. And that freedom for kids is what we are going to engineer to. Yeah, we're going to get our 80% reduction in fossil fuel, but we are going to give the kids the freedom back. Freedom from pollution, from congestion, from the danger of cars, yeah? So that's what we're going to do. Step 5 is we take what we learned from 2111 and we bring it back to today. And what we learned is that kids having the freedom to move about in their own town, to their own school, is a huge value and benefit that we can use. So that needs a trigger, and I think that those kids writing me those letters was a good enough trigger. That is going to cause some action. And we are going to now build a program that facilitates the children to learn how to engineer change in their own world, in their community, in everything they have purview over, and to reach even wider, to do what needs to be done. All right? So we built a program, and the program works through a process. It has activities, it has teacher training, it has tools, it has IT online tools so that the community can understand and see the progress, that they can trade trips, that they can do all sorts of things. And that, I can't tell you about the whole program right now, but on Monday, we're going to hold the transition tang. Part of a change like this, doing something that we don't know, it hasn't been done before. Anywhere in the world this hasn't been done before. We're going to be the first. We need a way for everyone to trust and understand what we're doing and for the community to go along with this. So we're holding a tang. We're going to explain to you the program. It's going to be set up like a judge and jury, so we do need people to come along to act as jury volunteers. And we will get the go or no-go on this. If it needs more work, if there's something that we hadn't thought of, it needs more work, then the jury will make that decision. If the jury says, I think you should go for it, then this is going to happen. So watch this space. The final step in transition engineering is that we're going to not do what we've done before, which is to say, okay, great solution, go, get the investment, build the factory. We will do that, but after we look forward to make sure there's no unintended consequences of our great thing that we just came up with. Because once you build the factory and the product line is going and the supply chain is established, there is no way to change that sucker except put assets at risk. So we are going to look forward now for every new thing we do. And that is going to be a huge contribution to engineering, because that's kind of novel. We haven't done that before. And so, like I said, come along to the transition tang and see the program that we're talking about. The guys here have been working on, I don't know if you can see the PhD students right here. They've been working on this, and they will be working on a lot more projects around Orkney in the next 3 years.
Okay, so just to talk to you as well about the Global Association for Transition Engineering. Susan and I both came up with this term, transition engineering, and we decided in 2011, actually, that we needed to have a body to bring people together. So an organisation to join people together, to enable lots and lots of people. We recognise that this is a huge challenge, so we need to have a mechanism to enable lots and lots of people to go out there and be agents of change. So we set up the Global Association for Transition Engineering, which is, it's a bit like a traditional engineering institution. We can already provide training, all different levels of training from CPD up to PhDs, thanks to Susan, and we will provide opportunities for networking globally and locally so that people can share the learning, share ideas, encourage each other, solve problems together. We will set standards so that if somebody's called a transition engineering practitioner, you know that they know what they're talking about, and that they can be trusted by customers, by clients, by community groups, by companies. And we will provide professional recognition for members. And it's like a professional engineering institution, but it's also like a movement. We've actually made it so that everybody can join GATE. GATE's a good name that Susan came up with. It's like you go through a gate. It's like a Rubicon. Once you've gone through, you're through. But everyone can join. You can join for free as an affiliate, which means you're part of the movement. Then you can join as an associate if you're studying or if you're working in a related field. And then you get professional recognition. You get letters after your name. And that's regulated by the Engineering Council, so that's really high value for people working in the field. If you're a full member, you get to be involved in decision making of the organisation, and we're currently working with the Engineering Council and the Society for the Environment, and we hope soon to be able to offer the qualifications Chartered Engineer and Chartered Environmentalist. So we're supporting people to go out there and do transition engineering. And there's a link there to our webpage. I can say that by the 7th of September, we'll have a new membership portal launched. So please have a look shortly after the 7th of September, and then you'll be able to join. So GATE is the body that we've set up to help make this happen. And then finally, Susan mentioned the Ting happening. So please get yourself on Monday at 2 o'clock to the ICIT for the Ting event. There's also 3 events, tomorrow, Monday and Tuesday, 11 o'clock in the morning at the Stromness Hotel, which I'll be leading. And the T for Transition events are an informal opportunity for you to come along and experience going through the 7 steps that Susan talked about, looking at your organisation, your company, your problem, your challenge, or we can make up a new challenge. But we'll go through the steps so that you can ask questions and explore what it feels like to go through those steps and ask some different questions and challenge some assumptions. So please do come along and join us. And we hope that with that, we have enabled you to think more positively and constructively about what you can do given this challenging news about real climate changes like Pakistan flooding, and use the technology, such as is currently being used to create rockets to go to the moon, for something more useful, let's say. So
to do what needs doing.
To do what needs doing, yes.
All right, well, thank you very much for listening to us, and we have time, plenty of time for questions. We moved through that at ramming speed, so that's good. And I don't want to underestimate how much work it is to set up a legal entity that is a professional organization within the framework of professional organizations in the UK, that is also a charitable organization, has its data management systems all set up. I was just doing the research and the investigations and tool development and stuff, and Daniel and the trustees in the UK went through that amazing amount of work to set up this legal entity, this professional body. In order for there to exist the possibility that we've talked about, that there is a different future that is engineered into existence, because that's what we do, this thing has to happen again, this transition engineering. So we've done all the groundwork, and it's ready to roll, and actually the phones are ringing off the hook. So that's where we're at right now. So thank you. Over to Howie.
And thank you both very much. That is fascinating. Questions have been coming in on the Slido system, and what I'm going to do, I'll give you the first Slido question to each of you, and then I'm going to pass the travelling microphone over to Michelle. So while The two speakers are answering the question. If anyone in the audience has a question, just raise your hand and Michelle will come over to you. But the first one that's come in, it's from Eric Walker, who asks about the point you made about the overall lack of motivation and real effort to take action. Is that connected, he asks, between this and the general feeling of mistrust between the public on the one hand and the professionals on the other hand and the authority? In other words, is mistrust underlying that background? Susan, first to you and then to Daniel.
Right. I've studied a lot the psychology of decision-making, of change-making, of processes to go forward, this sort of thing. Have any of you seen Indiana Jones and the Holy Grail? Yes, everybody has. All right. There's that moment when Indiana Jones has followed the trail, everything's crazy, he's trying to save his dad, and he's faced with this huge chasm. And he has some hint that there should be a way to get across there, but he just doesn't know what it is. And you have to forgive him for the 30 seconds that he spent not taking the first step, don't you? So right now, people not being willing to take action, whatever, I think that's where we're at. What action exactly is it that I should take? Okay, I know there's somebody doing a protest. I'll go take that action. I know that I can buy green offsets. You know, I know the business as usual things I can do, and people are doing that. ESG is a $1.5 trillion investment industry. You know, people are, they're doing what they think they can do, and that, however, can be a big distraction. We really do have to figure out what I think it's sand or something he throws out there, and then he can see it, and he still doesn't want to. It still looks pretty scary. But now he knows. And so that's the point we're at right now. So I don't want to spend even 2 seconds blaming anybody for anything, because I know where we're at. But I know the next thing to do is to get that understanding of where the forward footsteps are and get going on that. All right, fair enough?
I take that one and your one. Go there.
Okay. My microphone's still working, right. There's also an element, Howie mentioned trust. When you get to the stage of the process where you're looking at how to actually make the change happen, it becomes apparent that the barriers to these changes are not technological. We can do what needs to be done technologically. We've got the engineering tools. The barriers are people. As soon as you propose changing something, a lot of fear arises. So fear is a big human response to change. And whenever there's fear, everyone's nervous about making change happen. In a typical corporate environment in a company, probably in other environments as well, people are frightened to put their head over the parapet and say, I think we can change this. I think we can do something differently. And that fear erodes trust. So one of the key things that we do in the process is that we build a working environment in which we can get rid of the fear and build trust so that people can do things like share a common vision and get behind a common vision so that people can trust each other, get rid of the fear, and overcome that barrier. So the lack of trust, it's also partly generated by media, because fear and distrust and argument sells newspapers and sells clicks. So we have to understand that it's an overcomable barrier, the fear and trust.
Thank you very much indeed. I think it's wonderful starting with, in fact, my grandchildren's generation. That's the right thing. But here in Scotland, we've got this groundbreaking legislation, targets and everything, but we're failing to get anywhere near them at all in our achievement. So I wondered if you could comment on how we scale up from what you're talking about at that local level to that more higher level. I'm Roger Crofts, by the way. Thank you.
Okay, how to scale up? Well, I think we have to work at all scales. So we are starting small, but we know that we need to massify, if you like. We have built for scale, yes. So GATE starts off from the very beginning as a global organisation. Everyone can join globally. Everyone can access what we've got globally. But we do need to reach people. Hopefully events like this can help us to reach the decision makers. It's been very difficult in the past. From my perspective, it's clear that the communication between the engineering community and the policymakers has not been very good. The policymakers communicate a lot at national level in Westminster. There's a lot of communication between policymakers and the financial community in the City of London and the media community, but there's not so much communication with engineering. And I always refer back to the time in history when Isambard Kingdom Brunel walked into the Houses of Parliament and told them what they needed. They need a railway that joins the major cities of the UK. And he said, you need to change the law so that we can build this railway. And I've been in, we have parliamentary receptions in London, and I've spoken to parliamentarians who say they want engineers to tell them what needs to be done before they get round to launching a consultation. So we really just have to communicate as much as we can, and you are part of this. You know, you can all talk to your councillors, your MPs, decision makers at work, decision makers in the community, and we just have to get the message out there.
Right, and I guess from the beginning, I think it was in 2007 when we had that understanding that what we're talking about is that in this point in history, engineering has to step up and do what it has done throughout history. Whenever we have taken society down a dangerous path, we do our job and we correct it. And every engineer we talk to gets that. Then you've got the work of making it happen. So we're patterning on those previous disciplines, you know, safety engineering especially. I think what everybody says that climate change is different because it's that slow-moving disaster instead of, you know, the one-point disaster where everybody can look at it. Like my husband's a dam safety engineer. And that field did not exist before the Grand Teton Dam failed, and after it failed, it was just a couple of years, and it was a field, and people were coming together, and not really with new things, but bringing everything that was known to the purpose of that never happening again. Okay? So if there's anything new they invented, it was process. So that we know it can happen, and I guess what would really help is a massification of the demand for transition. You know, that it becomes just like safety, it becomes part of what you have to work through, part of due diligence. More questions?
Yes, another question which really follows on for that one, and I'll put it to Daniel first. It's about a phrase, critical thinking, that Professor Ian MacLeod gave a talk on in the festival last year, and he's going to be talking on aspects of that. And it's about the need to have the discipline, the self-critical discipline of the engineer, rather than the general vague optimism that many of us, and whether politicians or the public or in business, that many of us tend to carry through life. I'd like to put that question to Daniel, and then the roving microphone will go round again.
Thank you. I've got...
Oh, sorry, Susan. I'm swapping over. Rather, Daniel first, and then the roving microphone.
Okay, and first of all, I can't claim to know the work of Ian MacLeod, I'm afraid, but certainly thinking and how we think in response to a recognised problem, how we think is a really, really important thing. I've read quite a lot of the work of... and now the name's gone out of my head. The guy who invented the term lateral thinking, Edward de Bono, thank you. And he talks about thinking intentionally, using thinking as a tool to solve problems. And it is a really important thing if you are an engineer or a professional or a community leader. If you are asked the question, and I think this might count as critical thinking, if you are asked a question, you have to answer, instead of answering the question, you have to say, is that the right question to ask? So if somebody says, can you have electric cars? Well, yes, you can engineer electric cars, but is that the right question to ask? And if we always challenge, is that the right question to ask? And if we always challenge things like, what are the assumptions that are wrapped up in the question? So there might be a question, can we have 5,000 electric cars? Well, possibly we can. But what's the assumption? The assumption wrapped up in that question is that we have to keep on having more cars. And from a manufacturer's point of view, there's an assumption that you have to respond to every challenge by selling more stuff. So we, using critical thinking, have to say, is that proposal part of business as usual because it's trying to sell us another gadget, another device, or is it an actual solution? So I would say we have to make sure that we are answering the right questions and push back when we're asked to solve a problem.
And that requires honesty.
A lot of honesty, yes.
Oh. Was there another question?
You could answer that one.
Oh, keep going. All right. Yeah, I would say it would really help everybody if when you hear someone say a solution, right? We have a solution, because we hear that a lot, right? And everybody wants to have a solution. Obviously, we want solutions. But we have zero time to spend on the wrong solutions. So, is the solution this? Well, I don't know. If that was the solution, then what was the question? What was the problem? Because I need to knock that off pretty quickly. We're talking about 80% downshift of fossil fuel. Let's talk about that. Right? I want to hear that in every conversation about climate change, because that is the thing that matters. I try all sorts of analogies to get people to, to even say the words. And I'm down to resorting to using pictures of my granddaughter, asking for that, right? Just try saying it. Everybody, 80% downshift in fossil fuels. Wait for the lightning.
It didn't happen. No lightning happened, no earthquake.
Oh, so it's just a requirement for the project. Is that it, Daniel?
Yeah, I think so.
And what happens if we have 80% less fossil fuel? Well, in our school project, we get the entire parking area to use for school activities now. It can be converted to playground. It can have a hothouse on it, whatever the kids or the teachers think they would like to use that space for. There you go. Right? When, and the other one is, I don't want to say if anymore, when we achieve those downshifts, the amount of money we don't spend anymore on that thing, the number of accidents we don't have to pay for anymore, the huge amount of materials that do not have to be dug out of the ground to satisfy us being in a 3-ton carton of steel when we can do other things. The effect is huge, right? Okay. Oh, there was a question.
Yeah, well, we're just going over for the question now, a very short one for Daniel. Can we also think that a problem, however bad, can also be seen as an opportunity?
Yes, but that question can have two different answers, because from my background in industry, part of the business as usual problem is that industry, if you're in industry, there'll be a problem come up like sustainability, and the opportunity identified will be, we can sell more products. We can sell electric cars instead of petrol cars. Goodness me, that's an opportunity. That means we can sell 20 million new cars with electric motors to replace the 20 million that have got internal combustion engine. What a great opportunity. We can sell more cars and we can do all the marketing that says we're being green and sustainable. But that's not what I mean by an opportunity. The opportunity that we see is that we have got an opportunity, if now that we've got these tools for changing direction, going back to the car industry, in your car, you might have noticed that in front of you is a big wheel, yeah? That is a transition technology. That is a steering wheel that allows you to change direction. And every time you drive your car and you get to a corner, you have the tools available to avoid crashing in the corner and seize the opportunity of continuing your journey to where you wanted to go to, safe and sound. And we seize that opportunity so regularly and so comfortably that I would say nearly everybody who drives a car, when they turn around a corner, they do it so easily that they don't even interrupt the conversation they're having with the person in the front seat about what they're going to buy for dinner. So the opportunity is not to sell more stuff, the opportunity is to change direction.
Thanks. Neil Kermode, Chair. Thank you. Neil Kermode, Chair OREF, the Orkney Renewable Energy Forum. Thanks very much indeed for today. That's been really, really inspirational. I'm also a civil engineer by training, and I'm thinking back about the history of civil engineering, and that was very much about professionals getting together to discuss disasters that they'd had at the time, largely steam engines that were failing in mines. And that gave them the ability to have those conversations outside of their normal, across-the-table, confrontational approaches. So I think this is a really great idea, and I will be signing up by the end of the day. But above us, I work at EMEC, and above the door, we used to have a slogan before the wall was removed, but the slogan's going back up shortly, which goes back to something that Kennedy said in a speech in the Doyle, when he said, "The problems of the world cannot possibly be solved by the cynics and critics whose visions are limited by obvious realities. We need people who can dream of things that never were and ask why not." And I think that's exactly what this gives us a vehicle to do. Get those people who dream together and form a critical mass. So more power to you, Albo.
Thank you. Was that a question?
I think just say thank you. We look forward to your membership.
Thank you, Neil. Thank you. And we look forward to you joining and participating. And one of the things that we'll say in the process of joining, there's a big reminder that everybody who joins GATE, we ask you to volunteer to be part of the movement, part of the effort. So everybody can join in with whatever they can offer. So thank you very much.
And I guess one more thing about the movement, about transition engineering, is that this is the first engineering professional organization that has been organized with peer professionals and with supporters. So people who are for this happening can also be members of GATE. Well, not members, but associate members, right? Yeah. So we've set it up in a new way that we challenged the powers that be, but we got it done, or he got it done. That just foreseeing that the way that transition engineering works is so participatory. You do it with stakeholders, and it is also extremely legal, or local. And legal. Why is it local? Because all engineering is local, right? Just think about it. Daniel, what is the solution for getting across a river?
Bridge.
Bridge. Done. But no, which river? Getting what across the river? What's the soil conditions? You have to do the engineering project by project, place by place, group by group, purpose by purpose, reason by reason, all right? So that's what a discipline of engineering is about. And so participate, support, that's sort of where we're at right now, where we really are at a point where if you say the words transition engineering, Google it, move it around, it starts to become real. If you don't believe me, has anybody heard of donut economics? Okay, you doing that? right? Words are so powerful. They create a whole thing, and there's a whole story behind it. And right? So the words are important.
And the words have really been so well said today by you both. Now, just before rounding off with thanking you, I should mention we'll be back here at 2 o'clock when we're going back in time and traveling across to the heights of the high plateau in South America, finding the story of the origin of the domestication of potatoes and a link with edible clay. If you want to enjoy your potatoes over lunchtime, and there are fine lunches here as well, I definitely recommend not going for edible clay. But to find out there is a logic indeed, come back at 2 o'clock. For our online listeners and viewers, you've the opportunity as well, because at 3:30 we're going to look at the origin of another crop, and this is Orkney's ancient 6-road barley bear. We'll find out its origins go a very long way back. That's at 3:30. But in the meantime, to our inspirational thinkers and speakers for opening a fresh light into what seems otherwise to be a fairly dark future, the warmest thanks indeed to you, the audience here and online, and to our amazing technical team for making everything flow so smoothly and integrating all kinds of elements together. To you all, a very warm and hearty vote of thanks. Thank you indeed.
Thank you.